Hello everyone and welcome to section 2-1. Today we're talking about parallel lines and transversals. So let's just kind of break down what this means real quick before we jump into what these things are, right? Transversal is going to be a new word for us. So a transversal is a line that goes through or intersects two or more other lines. So you can see right here, I've got this line right here and this line right here. And you can see that there's a line coming straight down here that's intersecting right here and intersecting right here. So I know that that's going to be my transversal. So we made a little spot right here for you to write that, transversal. So again, this line going straight up and down is going to be that transversal. Well, when that happens, you can see that there are 8 angles that are made here. Angle 1, 2, 3, and 4, and angle 5, 6, 7, and 8. So I've got a lot of angles that are there. So today what we're going to explore is what happens if these two lines, let's call these lines, let's give them little letters. We'll call this line M and line N, and we'll call this T for transversal. If M and N are parallel to each other, those angles are going to make special relationships with each other. 1, 2, 3, 4, 5, 6, 7, and 8 are all going to have some special relationships that we can talk about over here. So before we get into this too, we got to talk about a couple things. Firstly, you can see that I have this exterior and interior piece written there. Exterior and interior. I brought some markers with me, and we're going to use these markers to do a little bit of highlighting. I'm going to go ahead and highlight interior with yellow and exterior with blue. And so what's going to happen is if you look over here, you can see that my exterior. Hello everyone and welcome to section 2-1, talking about parallel lines and transversals today. So we've got a new word right here, this transversal. You've probably heard parallel before. We've talked about that in Algebra 1, but transversal is a new one to us. So transversal represents a line that intersects with other lines. Specifically intersects with 2 or more other lines. So if you take a look here, let's go ahead and give some names right here. Let's call this line M, this is line N, and we'll call this line T. Notice how the M intersects line T right here, and line N intersects with line T here. So since T is intersecting 2 lines, T is the transversal in this picture. So we have a transversal, and we're going to specifically explore what happens when M and N are parallel to each other. When that happens, there's some special situations that happen with my 8 angles over here that we've gone ahead and labeled 1, 2, 3, 4, 5, 6, 7, and 8. For now, that is not an all the time thing. It's just for this case, those are the way we labeled them. So you want to pay attention to how those are labeled, but we're going to use that to make it a little bit easier to talk about them today. And so you can see I've got all these special angle pairs, and that is what we're exploring today. Before we get into that though, there is a couple things we want to pay attention to. Notice that I've got these words exterior, that I'm going to highlight in pink, and interior that I'm going to go ahead and highlight with orange. You can see I've got those words there. Those are going to be really helpful. Exterior means that the angles that are being created, notice how 1 and 2 and 7 and 8 are on the top and the bottom. They're outside of the two inside spaces. M and N creates an interior space and exterior space. So 1 and 2 and 7 and 8 are the outsides of that. Where you can see the inside or the interior is 3, 4, 5, and 6 because they're in between the 2 lines. They're inside of line M and line N. So that's going to be really important to helping us distinguish which ones go where. So let's take a look over here. The first one says we want to look at alternate interior angles. So I'm going to go ahead and highlight this word interior. That's going to be really important. Interior. Well, if you're an interior angle, we just said, we know that means that you have to be angle 3, 4, 5, or 6. Those are the only interior angles, meaning those are the only answers that we should get for alternate interior angles. Those are the only things we should be talking about. This word is also really important, alternate. Alternate means different or opposite. This means that the 2 angles we're choosing have to come from different sides of the transversal. Notice the transversal is kind of split up. We've got a left side of the transversal. Left side has 1, 3, 5, and 7 on it. So that's my left side angles. The right side would be 2, 4, 6, and 8, my right side angles. So if I say alternate, I'm telling you that you have to pick 1 left and 1 right angle. And I'm telling you, both of them have to be interior. So if I were to come over here, 3 and 4 are on alternate spots, right? 3 is on the left, but 4 is on the right. And they're both interior. But if you picked that, you wouldn't be right because 3 and 4, we know what 3 and 4 are already. That's something we've talked about before. That is a linear pair. We've done linear pairs before. We're not going to give those a new name. We know that those are already. In fact, I'm going to add those into my notes down here. We're going to add that right down here, and we'll come to that in just a few minutes. But linear pair is something we already know that we're going to use today. No, 3 would be alternate interior to the other interior angle that is also inside. And you can see that's 6. Notice how 3 is on the left, 6 is on the right, and both 3 and 6 are interior. So that would be an alternate interior pair. So what's important is that you're picking one angle from up here and one angle from down here, one from each quadrant. One has to come from the top, one has to come from the bottom for majority of these, which means the other alternate interior pair would be to 4. 4 is on the right-hand side, so the one that's also inside, but on the left side is going to be 5. So angle 4 and angle 5. So my next one is going to be alternate exterior. So this time I'm looking at the angles that I called the pink angles. That's going to be 1 and 2 and 7 and 8. Same idea. Alternate means opposite sides. So 1 and 2 are already a linear pair. You're not going to call 1 and 2 an alternate exterior pair because they're already a linear pair. They already are adjacent to each other, all that. No adjacent pairs. 1, go all the way down to the other cluster. The one that's also exterior but on the opposite side is the 8, 1 and 8. So angle 1 and angle 8. And my other pair would be then over here. The 2 on the left-hand side is the 7 on the opposite side, so 2 and 7. 2 and angle 7. And I'm going to come right back up to this corresponding. Let's go down to do these same side ones, just so we can talk about that as well. Same side, or sometimes called consecutive. These two words go interchangeably. Same side and consecutive mean the same thing. Same side, I think, makes a little bit more sense, a little bit more clear what they're saying, right? Same side means they're on the same side of the transversal, or the consecutive side. They're consecutive to each other. So we're talking about exterior first, so let's highlight that with our pink. Exterior, so again, we're only talking about 1, 2, 7, and 8 here. My 4 exterior angles. Well, if you look at 1 first, angle 1, what is on the same side as 1, but also exterior? Well, there's only one possibility. You're not even going to mix that up with linear pairs, because the only one that's on the same side of the transversal, the left side, is going to be 7. Angle 1 and angle 7 are both left side and in the exterior, which means angle 2, which is on the right side, its exterior same side pair is the 8. Angle 2 and angle 8. And then we got the same side interior, so now we're going to highlight with the pink. We're thinking about the interior angles. We're thinking about 3, 4, 5, and 6. So starting with 3, the one that is also interior and on the left side of the transversal like angle 3 is going to be angle 5. Go over here and do the other one. Angle 4 is on the right side. Angle 6 is also on the right side and interior, so 4 and 6. Going back up here, corresponding. These ones can kind of be a little bit weird, but think of corresponding as if I picked up, if I were to pick up angles 1, 2, 3, and 4 and drop them on top of 5, 6, 7, and 8. The ones that land directly on top of each other would be the corresponding pairs. So if I pick 1, 2, 3, and 4 and drop them onto 5, 6, 7, 8, well, 1, 2, 3, and 4 are going to be in the same spots as 5, 6, 7, and 8. So my first corresponding pair is that 1 and 5 are going to be on top of each other. 2 is going to pick up and drop on top of 6. So 2 and 6. 3 is going to drop on top of 7. Ooh, why did I put an 8? What? Excuse me. Excuse Mr. Nakarada. What am I doing? 7, that's better. And then 4 is going to pick up and drop on top of 8. I had white out somewhere, but I don't know where it went, so we're just going to leave that scribble there. It adds character to the notes. And then we're going to come down here and look at our other ones, right? Vertical angles. We've talked about vertical. In fact, we talked about vertical and linear pair before. Vertical angles are angles that are opposite of each other. So in this one, if you looked at 1, now notice all these ones came from one pair from the top 4 and one of the pairs from the bottom 4. So one from here, one from here. Vertical linear pair do not do that. Vertical linear pair when they come from the same set. So angle 1 and angle 4. Notice how they're opposite. Remember, that's a vertical pair. We've talked about this before, but just to reiterate, 1 and 4 would be a vertical pair. Another example might be, let's come down here and look at angle 6. Well, what would be vertical to angle 6? How about angle 7? You can see that there's also a few more options, and I don't really have the space to write, so I'm just gonna put etc. But 1 and 4 are vertical, 2 and 3 are vertical, 5 and 8 are vertical, 6 and 7 are vertical. There's 4 different pairs that we could use. Linear pair has the same idea. Let's start up here. Angle 1 is a linear pair to angle 2 and a linear pair to angle 3. It's got 2 options. It could be a linear pair here or a linear pair here. Let's put the 1 and 3. Angle 1 and angle 3. If I were to come down here, how about 8? What is the linear pair to 8? Well, 8 could be a linear pair with 6, or it could be a linear pair with 7. So let's go ahead and put maybe 8 and 7 for this one. Angle 7 and angle 8. And again, we're going to put etc. here because 1 and 2 are a linear pair. 2 and 4 are a linear pair. 4 and 3 are a linear pair. 3 and 1 are a linear pair. 5 and 6. 6 and 8. 8 and 7. 7 and 5. There's 8 different linear pairs there. We don't need to write all that. We've talked about that before. Just remember that if there are 2 angles side by side that make a straight line, we know they're a linear pair. Well, this is going to give us some important things. Like I said, these create some interesting relationships that are really important for us. The first is that some of these relationships are angles that are congruent to each other. Angles that are congruent to each other. So what's going to happen here is whenever you have an alternate pairs are always going to form congruent pairs. So my alternate, and I'm going to abbreviate a little bit here, alternate interior angles are going to be congruent to each other, as are alternate exterior angles. Corresponding angles are also going to be congruent. And just to kind of throw that in there, we've talked about vertical angles before, and we know that. We know vertical angles are also congruent. So vertical angles could also fit in here if you wanted to add that in there. Vertical angles also fit into the set of congruent angles. My next one is the supplementary pairs. So in my supplementary pairs, well, you can kind of see they're grouped together. These are my congruent pairs up here. These 2 are my supplementary pairs, my same side interior and exterior. So I'm going to put same side interior angles and same side exterior angles. And we also know that linear pairs fall into that too. So if you wanted to add that to the category as well, linear pairs are also supplementary pairs. So with that, that gives us all our pairs. Let's go ahead and look at these examples down here. In fact, right over here in this reflection spot, I'm going to show you a little helpful tool that I use. It's called ABBA. 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 ABBA is a group from the 60s and 70s. They sang, "You are the dancing queen, young and free, only 17." Yep, that's on recording now for you all to hear all the time. So with this, what I can do is I can actually use those words to help me. I'm going to take the word ABBA, ABBA, and write it twice. A, B, B, A. A, B, B, A. So we can use that to solve these algebraic problems over here as we move forward. So if you take a look, this first one says, given that the measure of angle 6 is 142 degrees, and the measure of angle A is 53 degrees, find the measure of each missing angle. I'm going to start here first. There's clearly 2 problems here. The measure of angle 6 goes into this one, but the measure of angle A goes into this one. So let's do the measure of angle 6 first. So it said the measure of angle 6 is 142 degrees. So I'm going to put that right here, 142 degrees. Now, because these 2 lines are parallel, that means this ABBA, ABBA idea works from up here, that all these things are true. So I'm going to go ahead and put ABBA, ABBA in. ABBA, A, B, B, A. And then in the next 4, A, B, B, A. Here it is. This is how simple this is going to be. All of my B's, right? All of my B's are going to be the same. That's what ABBA, ABBA tells me, is that all of these B's are going to be the same. Specifically, if we're going to give reasons, 6 and 8 are going to be equal to each other, congruent to each other because they're vertical. And we know vertical angles are congruent, so I can put my 142 over here. I know that 6 and 4 are alternate interior pairs, so that means that they are also congruent. And I know that 4 and 2 are vertical, so this is also going to be 142. I also know that 4 and 6 are corresponding, so that makes them equal. I know that 2 and 8 are alternate exterior, so that makes them congruent. Lots of reasons. To get to these other ones, whenever you have an A and a B, they're going to be supplementary. So let's write that over here. A is always equal to A, and B is always equal to B. If you have an A and a B together, A plus B always has to equal 180 degrees. That's going to help now because I don't know what A is, but I know what B is, so we just do the opposite. We take 180, we subtract that 142 from it, and let's see, that's going to be a 7 and a 10. 10 minus 2 is 8. 7 minus 4 is 3. 1 minus 1 is 0, so I got 38. Well, that tells me that all the A's have to be 38 degrees then because that will add up to make 180. So 38, this A is going to be 38, this A is going to be 38, and this A is 38. And there are all 8 angles. So if we come over here to the second part, right, they told us that the measure of angle A is 53 degrees. So this is going to be my 53 degrees right here. We're going to put our ABBA in, but we're not going to confuse ourselves. This A and this B are not the same as this A and this B. This is the ABBA A's. These are the actual angle A's. So let me put another BA, ABBA. Okay, we know all our A's are going to be 53. So this is 53, this one's 53, and this one's 53, and this one's 53. And just like we did before, we take 180, subtract the 53 from it. So 7, 10, 10 minus 3 is 7, 7 minus 5 is 2. I get 1 minus 0 is 1, so I get 127. So I know that this angle B is 127, this angle B is 127, this angle B is 127, and this angle B is 127. Bam, look how easy those are. With that, let me be mindful. Look right here. I said this earlier and I'm going to say it again. Notice how this went 1, 2, 3, 4, 5, 6, 7, 8. It went around like 1, 2, 3, 4, 5, 6, 7, 8. That picture doesn't do that. That picture went 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. This one went over, 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 over. This one went over and around, over and around. These numbers are not universal. They do not always stay the same. You always need to pay attention to what numbers are here so that you can write the right things. If you just memorize that 1 and 7 are always same side, which would be harder than just learning how it works, but if you memorize that these are always how they are, you'd be wrong. This is just one example. This is just another example. This is a third example. They can give it to you in lots of different ways. So just make sure that you're understanding the concepts of what same side means, what exterior and interior means, what alternate means. That way you're not having to try and memorize the numbers and where they go. All right, coming down here to example 2. Example 2 says if L is parallel to M, that's what this means right here. L is parallel to M. If line L is parallel to line M, find the value of the missing variable. So we're going to do our ABBA here. It's going to help us. A, B, B, A. A, B, B, A. Let's do a little circle. So you can see that this 5x minus 2 is a B. This 58 is a B. Specifically, if we wanted to name that angle pair, if we thought about this angle pair, well, 58 is exterior, and the 5x minus 2 is interior. So we know it's not an exterior and interior pair, like alternate or same side. But what I see is that if I picked these 4 angles up and dropped them on top of these angles, the 58 and the 5x minus 2 are in the exact same spot. If you picked this up and dropped it, they would land on top of each other. So I know that this represents a corresponding angle pair. Put corresponding angles. But then when I go to solve it, we could look back up here. We can see, oh, we know corresponding are congruent to each other. Or we just did our ABBA trick. They're both the letter B. We know that B is always equal to B. So we're going to set those two things equal to each other. So I'm going to set 5x minus 2 and 58 equal 5x minus 2 equals 58. And we can go ahead and solve this. Put my line right there to represent where my equal sign is. We'll add 2 to both sides of the equal sign and cancel, and I get 5x equals 60. And then we'll divide both sides by 5. X is going to equal 12, and that is the answer that I needed. Taking a look over at this next one. Again, we got to do our ABBA. The picture changed a little bit, so you could turn your paper. You could physically turn your paper and do ABBA this way, or you can just change the direction you're going in ABBA. As long as you always go across, you're fine. I'm gonna go right here and go ab-ba in these four. Again, notice I went ab-ba. And then over here in these four, go ab-ba. You're not gonna go abba, abba. That's not how it works. You do in the four, abba, abba. Taking a look at my things, it looks like this 9x plus 2 is pointing right here. So it really goes into that spot. They just didn't have enough room to write it. But I can see that that is a B. That is the letter B. And we can see this 133 is right here, and that's the letter A. Well, we know what happens if you have an A and a B. They add up to make 180. Specifically, if we looked, the 9x plus 2 and the 133 are both inside the two lines. Here's my two lines. They're both inside. Remember, this arrow's pointing inside here. So it is an interior pair. And you'd ask, are they on the same side of the transversal or alternate sides? Well, they're on the same side. They're both on the top of this transversal. So I know that this is a same side interior pair, which we know we said are supplementary. They add up to 180. Again, that was told by Abba Abba. Abba Abba helps us kind of remember that and not screw that up. So these two should add up to 180. So it's going to look a little different. Here we set them equal to each other. Here, we're going to add them together. 9x plus 2 plus 133. You can do it vertically like I just did here, or you could write 9x plus 2 plus 133 horizontally all in a row. Either way works. 2 and 133 makes 135. Bring down my 9x. And we know this has to equal, because it adds up to 180. They're supplementary. It has to equal 180. Subtract 135. Subtract 135. That's going to cancel, and I have 9x equals 45. And my last step, divide by 9, divide by 9. X equals 5. Done. All right, let's bring it home. One more. Again, let's do our Abba Abba. So now this is kind of in the same order we started with. So A, B, B, A. A, B, B, A. We can see that this one is a B. This one is a B. Well, if they're both B's, we know what that means. It means they're going to be equal to each other. Let's verify that that matches with our thinking. These are both interior, right? They're both inside lines L and M. So they're interior angles, but one is on the left while one is on the right. So that means they're alternate interior angles. Again, though, because they're both B's and because we know alternate interior means they're they're congruent to each other, we're going to set them equal. They are equal to each other because they are both the same letter in Abba Abba. Okay, I like to always get rid of the smallest x first, so we'll subtract 5x from both sides. That will cause those x's to cancel. 13x minus 5x is 8x. Bring down that negative 21. We canceled there, so we just have a 75. Since I moved my x's to the left, I gotta move the 21 to the right so that I can have one thing on each side of the equal sign. Bring my 8x down. That's gonna give me 96. Well, now I just gotta divide by 8, and I get x is equal to 12. Boom, 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 boom. So that covers all that. This will be super useful. These definitions up here will come back all year long. So you're gonna wanna make sure you keep this in a nice, safe, neat, orderly way so that you can come back and reference it. And let us know if you have any questions. Thank you so much for tuning in.